Okay, so I had a request from a friend on how to design a special H block that he was going to print. This is the base H block from a inline skate frame, aggressive skate frame that he had. Gave me some dimensions of about 90 long, 40 high, 27 wide, and he wants it to fit this frame, but to sit over the groove all the way to the width of the frame. So I'm just going to roughly show how I would do this. I don't have all the dimensions, but give it a go here in Solidworks. He's a Fusion user, but Solidworks, Fusion have fundamentally the same way of working. It should work similarly in both systems. If I was working in something else like NX, there's about 45 different ways to do it, whereas in Solidworks there's about 20 different ways to do it. So this is not by any means the one way to do some solid modeling in SolidWorks. It's a way that I do it, and I could probably come up with 5 in the next hour, and 5 different ways in the next hour, and do them all, but this is just one. Alright, because I like to see all my planes to start with, I'm just going to turn them all on. That's user choice. I'm going to start on the front plane with a sketch. If I can remember where my sketch is, we start with a very simple block. That was a little weird, but I'm going to use some constraints just because I'm going to center it on the planes, because that's just what I do. So I'm just going to lock this down to this plane, and it didn't quite work the way I wanted to, but anyway, the buttons are all there. Make that coincident, so we're going to make that 90 by 40. And 40. Alright, so that's our starting block. We'll extrude that. I'm going to extrude half of the 27, because I just like to mirror things after if they're symmetrical. In fact, I could mirror it twice because it's theoretically symmetrical about both its center lines, but I'll do a full profile. It needs to be 27. I want it to be 27 on 2. Alright, so we could sketch on the front plane again. In fact, I probably will just sketch on the front plane instead of on the, actually, you know what, I'll sketch on the back face. So trying to like just roughly figure out the profile. He wants it because he wants it to sit over this profile here. I mean, that it's hard to tell from the images, but it's sort of got some curvature to it. It's not quite flat, so I'll design it like with a radius to these faces and then put the blend in here. And this is not perfect because I don't have the skate in hand. This is just, if I had all the dimensions and the skate in hand, I'd be dimensioning off it. But we'll just rough it in. So we're going to do a couple of arcs here. These are going to end up being the same radius. I know my skate key is not working, but apparently it's not. Fortunately my control key is, so actually I did not want to make that coincident. Actually I did want to make that coincident. Make that coincident too. Didn't work. I'm gonna make these the same. Having trouble clicking today. Make these not concentric. I'm going to make them equal length, and I am going to make them not cordial. Where is my equal radius? Equal, make equal. Okay. Because what I am going to do is put this on this curve. this curve, on this edge, I should say. And then I am going to draw the rest of the profile real quickly. This is very rough. I'm not doing anything perfectly. Currently looks like a bit of a bum. I still don't understand why my escape key's not working. So it's going to end up looking something like that. So let's just put some dimensions in here as a starting point, and a really big radius. Let's go 160. I do want to overbuild this. Like I said, this is going to be very rough, so I'm only taking a guess at how far it needs to be from the center. I mean, if we take a look at the picture, that there versus that there, I mean, there's the center line there across the axle holes. That's up a little bit higher, so I kind of want to dimension it from here to that point there. We'll call it 8. I'm going to overbuild. I'm going to overbuild this here. I'm going to make that just nice and big for now because you'll see why later. And then what are we missing? We have a radius there. We have that dimension there. Let's just see why. I think I know why it is. I'm going to have to get used to my escape key. So it's this here. You see we can still move that up and down. So I will set that height based on this as well for now, because that's probably the best way to drive it. That is now a fully defined sketch in Solidworks here. At a guess, we'll call it 18. I have no idea what the real dimension is. I have not put the radius in the middle here. I like to do that as a fillet later. So we'll exit that sketch. Is my spacebar working today? It is. So then I would extrude that. I would go in the other direction because we are going to unite it to this, and we would make it wider than the frame. I don't know how wide the frame is. You know, it was 13.5 for half the frame before. Let's just call it I don't know, 18. Let's see what that looks like. So you see it hangs over. So we like that. It's united. I left that to combine. So now I have effectively an overbuilt H block. And then what I would do is we'll just sketch on this face. We'll sketch on there, and what we're going to do is, again, we're going to overbuild, and you know, I'll probably cheat a little bit here. I'll just make the first bit of the profile. Really wish my escape key worked. I don't know why it's not working. I'm going to put the first bit of the profile here. I'm going to actually go across here and I'm going to make that construction geometry, just because I like construction geometry sometimes. And then, you know, I want to do something to kind of make a groove here. The natural groove in this, it actually has flats either side and a groove, so let's just do a profile like that. So I'm getting sick of this escape key not working, but whatever. I'm just going to arc that like it's a groove. So I want these two to be equal length. The cool thing about, I guess, designing your own H block and printing it is that you could probably you know, offset and make these grooves different if you kind of wanted to bias the groove for some weird reason. If you kind of find that biasing the groove or whatever will help you with your skating. Nothing helps me with my skating. I'm just bad at it, so I just live with whatever the frame comes with. But some people like custom things, and 3D printing things like this is a good way to get that. So here's how to design it. Let's see what we've got left here to make this fully defined. About 70 groove for now. You know what? 70 looks a bit big. Let's make it 60. It's a little deeper. Gotta get that lock on. It's a little bit over a 2-inch outside diameter, so that should lock around nicely. maybe 65, but anyway, let's just dimension this up in length. 12ish sounds good. Let's just see what else. It's missing the height here. So that's fully defined now. In fact, I probably shouldn't have dimensioned that from there. Where I should actually dimension this from, let's get rid of that one. I should actually probably dimension this off. Let's dimension it off here. Maybe this is not the right dimension to drive it either, but I'm just going to use that for now. Maybe you need to dimension it off the center line. You know, choice is yours. But that's my profile locked down. It's fully defined in this case. So let's get out of the sketch. And then what we're going to do is do an extruded cut in this case. I'm sure it's called different things in different software. It's definitely called something different in X, which is my preferred software, but I'm not rich enough to be able to afford that. It's just a day job thing. So we're just going to extrude a cut. It says blind. I'm going to go through all, just to make sure that if we ever change the width, it would always go through all rather than be set to a blind dimension. That way, if we widen it, it will always follow the width to cut through everything. So that's that. The one thing I didn't do that I said I was going to do before was put a little fillet in here. Let's put a fillet on there. Let's make a nice big 30, just because it looks like it's something like that. And, you know, I'd print a little test of this profile. I actually could cut down a smaller area and just test to see if this was the right solution. The other thing I mentioned to this person, and this is a little bonus here, is I like to do either diamond or teardrop holes. So I'm just going to give a little sample of both since we're talking 3D printing. Let's do a sketch. Let's do a couple of different sketches to show you one of each. Let's go with, every time I flip between systems I have to remember what I'm doing. So I'm just going to do a little bit of construction geometry. Let's do the diamond one on this side first. I don't know how many times I'm going to say I wish my escape button was working today, but it's not. I need to probably restart my computer knowing me. So let's do the diamond one first. This is, I don't know if this is the right way to really construct it, but it's kind of a lazy way to do it. It's just 4 rand. So we make them all equal length. That chose the wrong thing. That chose a midpoint. Let's try again. Probably just hold control and not hold midpoint, but anyway, whatever. Make equal. If we make 2 of them perpendicular, that will turn it into a perfect diamond. That one, for some reason, I did put on that plane, so you see it's locked to the plane. I wasn't planning on locking it to the plane, but it did. Oh, well, I was planning on locking it to the plane, but not just yet. But anyway, it is locked. And then what I'll do is make this tangent to my construction hole. So that's that. And then make another one tangent. Make another one tangent to my construction hole. And there you go. What we didn't actually do was define much. He said that it's an 8mm axle that this runs on, so just make it 8 as an inside diameter since it's circumscribed. And then he said the offset was, I think, 7.5 from the end of the H block, so that locks that down nice and easy. Then we can go and do a get out of that. Let's just cut that, extrude a cut, through all, done. So that's a diamond hole. So that's an example of a diamond hole if you're printing from the bottom up in this case, which is the way I would tend to opt to print it. I guess the other way you could print it is from one end. That might be another good way to print it. That diamond hole will work for both. In fact, I probably would print this one from an end. I'd probably print this one from one end. In fact, I'll show you what I'd do for a teardrop hole. if I was printing from one end. It's not really gonna, you'd have to extend this end to make it work. I don't know if that'd fit in this frame, extending it, but I'll show you a teardrop hole if I was printing from the end, because that would be a no support print that way if we printed from this end to that end. So once again, let's do another sketch. We are going to do, I'm just going to do some construction geometry again. I don't really need to do construction geometry for this one, but I'm going to because I'm feeling a little lazy. I did not do what I wanted to do. See, I'm clicking off a lot because my escape key is not working, and I'm sure everybody's sick of me saying my escape key is not working. I'm going to do another, you know what, let's just call that the 8mm. What is with my escape key? Maybe I need a new keyboard. Let's just make that the 8mm hole now. And we'll set the dimension from the end like we did before. This 0.5. What I'm going to do is draw, I'm going to overbuild this for now, or make it a bit bigger for now. I'm going to draw, that's a circle, I want a line. I'm going to draw a line from here. You can force it to be tangent, force it to be tangent here. I think that's got the tangency constraints. Let's see if it did put tangency constraints on that. Oh, apparently I got out of my sketch. Apparently my escape key started working, unless I'm not hitting escape. But anyway, it did not give tangency there. Did not give tangency there. So let's go and make them tangent. 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 This here is going to end up on that plane there. Ooh, it did not like that. I've got something. This is locked to horizontal. I need to get rid of that horizontal coincident. I think I've broken it. It's not showing. I think I locked this to 45 or something. Oh, it's perpendicular. No coincident tangent. Let's start that again. Let's do these two lines again. Sometimes I just need to start again. Okay. No, my escape key's still not working. Put that. Let's put that on that. Coincident. Put that. That's not meant to be coincident to that. This is meant to be coincident to this. Okay. This is meant to be tangent to this. Tangent. This is meant to be tangent to this. Tangent. These are meant to be equal length. Equal length. I don't even know if I needed that, but the key here for me with this teardrop hole, I mean, this is a, you can make it this, but if you force this to be these two lines to be perpendicular, oops, that's not what I wanted. If you force these two lines to be perpendicular, then that should force that to be 45 degrees to the plane, because they're perpendicular, and this point is on that plane. So that's now a teardrop hole that theoretically can be printed. Now 45 may not be the best to print. It's a little bit too overhung for some people, but theoretically that should print nicely. What I do need to do is trim that bit so you can see the full profile, and then because I made, oops, I was still on trim, make that and that not equal length, make equal. So now my profile is sitting on that 8mm hot construction hole. And then, now that sketch is done, we can do an extruded cut on that. Through all, done. So that's half the H block, and then all we've got to do to make the other half of the H block is, if I can remember where my features are, Somebody yell out if you can see mirror, because I keep forgetting where I put it. It's somewhere in this pattern. It's under this mirror. So I actually want to mirror, it gives me extruded cut. I don't want that. I actually want to mirror the full body. I don't know why Solidworks doesn't let me automatically give me the body option. So we want to mirror that, and the face that we're mirroring against, you can either choose that. Let's just choose the face of the body, because that'll force it to always mirror about itself. And then we're done. That's it. That's an overhung H block. You know, it's parametric here in Solidworks. I've never been a very good Fusion user to really get parametric modeling to work well. But you know, if this, for example, if this overhang is not quite long enough, it's not the sketch we want, we can edit that feature and we can make it go, say 22. Now it's overhanging more. You do that, and because everything else was developed using parametric features, well, now the overhang extends on both sides, the cut goes all the way through, the holes go all the way through. So that's it. That's how I would do it. That's one way I would do it. But there are definitely other options to being able to do this, and there's probably about 5 other ways I could come up with within the next 30 minutes to do it differently. So there you go. That's an H block in Solidworks.